Alright class, Assalamualaikum and very good afternoon. Again, for today's class, I'm going to explain to you about auxiliary projection. Now you may find this a lot in the other YouTube channels. You can also view it from other websites as well, what auxiliary projection is. Today I'm just going to explain to you a little bit about auxiliary projections and what are its importance. So this is part of the axonometric view. However, auxiliary projection involves in inclining surface. So where the parts where the inclinations are, where you cannot draw, where mostly you draw based on the front view, the side view and the top view, the auxiliary projection views allows you to draw it in a slanted way. So this lesson we will explore how to draw these views on the planes that are parallel or inclined to the surface. So auxiliary view are known as the helper's view. Okay, when the object has inclined surface, they do not show up in true side shape. For example, you take on this view, the front view, the side view and the top view. Mostly what you cannot see is the is the slanted of this top view or this view. You do not see the face. This side also you cannot see it if it's slanted or not, but basically it's very slanted. So a view on the parallel plane to this inclined surface does not show its true shape. This is called the auxiliary view. This is an auxiliary view. It, along with other regular views, describes the object better. For example, this is a partial view of the side view and the bottom view, for example. The front view, the parallel lines from the front view can determine the slanted shape of the views. This is called the auxiliary view, and we were going to explain to you how to draw this auxiliary view using our technical drawing. Now, why do we use them? Well, the most important thing auxiliary view projects are the plane parallel to the inclining surface. It views when you look directly at the inclined surface in a directional or perpendicular to it. And the auxiliary projections are important for describing the true geometry of the shape. Whereas if you look at previously, the geometry of this doesn't explain the angle, whereas this one you explain the true projections of the length. And you can also use them for dimensioning these shapes. Say we look at this orthographic view. If you draw like this, you will not know if this is slanted or not. What you know is that this is drawn like this. Okay? None of these views explain the slanted surface, which is this A here and A here. It doesn't explain you. It only explains you the depth and the height, but it's not the real one. Same goes for the top view. The M and N shows the edges of the line, but the line is actually very slanted. By looking at the surface of A, it is little short-sighted. Okay, surface A is actually appears more different than what we are looking at from this orthographic view. So by using an auxiliary view, you can actually understand the true slanting area of this front view here, or also the top view here. So by taking the area by its true shape, you have to imagine that the line from this front view has a parallel line. In diagram B, you can see it's parallel to the line of the isometric view, but in this one you can see its parallel line is parallel to the orthographic view. The first thing you should know is that it is perpendicular to the slanted line here. That is first angle that you have to draw. the first line that you have to draw. Later on, you just follow this line by calculating the 90 degrees from the perpendicular line, where you can get the shape of the real shape of the auxiliary view. So another way to draw this, for example, step-by-step directions for making. First of all, is by examining the view that are given for the inclined surface. So if you are given a orthographic view of this one is a what? This is a second projection view, because it's on the front view is actually on the second projection view. This is not the first angle or third angle view. It's a second angle view. B, find the line that is considered the edge of the view. So identify the view of X and Y. So this one is a slanted view. C, in the front view, draw the front view here. You draw a light construction line at the right angles to the inclined surface. This is the line of the side. So basically you have to draw this line, which is a right angle to the inclined surface. Finally, or you can just draw a perpendicular line. So you draw a 90 degrees from this inclined surface here. Consider one or two hinges. Think of the auxiliary plane by attach a hinge to the front of the vertical. So like a hinge here, you draw a hinge from which it is developed. So basically from this view, you have a line, slanted line. Make this A plane here like a hinge. Okay, a hinge which is perpendicular to this slanted line. Now you have an auxiliary view. E, draw the projection. Once you have imagined this slanted line here, you draw a projection by taking a length, okay, from the front view. Draw the projection line at the right angles of the incline. So from here you draw the depth, you calculate the depth of this one, which is the same as the depth of the top view. Draw the reference line parallel to the edge view. The edge view here, you have to draw a parallel line, another parallel line or a perpendicular line from this one. Transfer the depth dimension, which is in this case the primary reference, to the reference shown. Draw the second, the third and the fourth. Once you have known the depth, you can draw a rectangular line, 1, 2, 3 and 4. Project the label points. So from here to here you have to make sure that it's the same length. Don't confuse it. So project the label points and connect them in sequence to form the auxiliary view. Like I said, 1, 2, 3, 4 in sequence, and point used to identify the shape for the solving difficult problem. Okay. However, there is also a way to draw the auxiliary view using a center plane reference. Say in diagram A, the object is shown in a pictorial view, okay, or an isometric view. A pictorial view is not an isometric view, but something like an isometric view. Because the object is symmetrical, you use a center plane as a reference plane to make the auxiliary view using the following. First of all, this slanted line X and Y here. First of all, you draw the parallel line, and then the diagram B here represent your center plane as a reference. So next you draw the edge of the view plane. You draw this X and Y, you draw the edge of it, the 2, 3, 6 and 5, 1 and 4. So you draw this perpendicular line. Then transfer to the edge of the incline shown in front. So once you have drawn the perpendicular line parallel to the edge, you have the auxiliary view already. Now the X prime and Y prime are shown, drawn to the left. Now take the dimensions from 1 to the center, 4 to the center, and 1 to the center to the 1. and so also 5 to the center and center to 6 to draw the dimensions. Do the same for this other side. Okay, so basically your figure will not look the same as the top view, but rather more like an auxiliary view. So this is the correct view. It's like an ellipse, but it's a more corrected view of the angle of this one. Okay, it does look more correct, but this is only for a plane that is similar on the left and on the right side. What about if you have a center plane reference method? Okay, an example of center, by looking at that, you can draw the true size and the shape of the center plane. What about this one? How do you want to draw this one? So remember, draw a perpendicular line first, 90 degree. Draw an x and y length, and also an x and y length on top. Divide the side view into a couple of lines, 1, 2, 3, 4, 5. Make the projection of 1, 2, 3, 4 and 5, and then project this to this line, like that, to the x prime and y prime plane. Draw the value or with the depth from 1 to here, 2 to here, 3, okay, and so on. And then you have the ellipse shape of D1 from here to here, D2 to here to here. Okay. So make sure this is a practice. Make sure you can practice this at home. Try to draw this. Follow the simple plan that we have already discussed, and also the output should be okay. This is the first one. The second one, example here, I want you to draw this. Try to do this in class by understanding the auxiliary view. Okay, so here are some of the practices you can do at home. Figure 3.2, where is the slanted line? 7.34. This one, this is the slanted line, this is the slanted line, this is the slanted line. Okay, the ones from page 2, okay. You can also do this in this page as well, the slanted line, finding the slanted line of this one as well. Okay, you can do this exercise at home. Okay, that's all from me on auxiliary view. Thank you for listening.